Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to explain example 1 in Algebra 9. And we are saying that solve the simultaneous equations y is equals to x plus 6 and y is equals to 2x squared algebraically and show the result graphically. Now, algebraic solution, we have the two equations, y is equals to x plus 6. That is equation 1, we can call it equation 1. And equation 2, we have y is equals to 2x squared. The two equations are talking something about y, and therefore, because this is now equation 2, which is also talking about y, we can always have equation 1 equals to equation 2. So by substitution method, equation 1 is equals to equation 2. So because both of them are talking about y. Since y is equals to y, then we can say 2x squared is equals to x plus 6. And this one is going to be a quadratic equation, so we can always let it be 2x squared minus x minus 6 is equals to 0. And in this case, we would want to talk about factorization method. There are several methods to use. We can use factorization method, we can use completing the square, or we can use the quadratic formula. But for this one, I think the factorization method is just straightforward. We have in general our equation ax squared plus bx plus c is equals to 0. In this case, you can see our a is 2, our b is minus 1, and our c is minus 6. Using factorization, we can look for two factors. When multiplied, they will give you a c, and when added, they'll give you a minus b. We have, I call it BAC approach. BAC approach is just factorization method, where our b is -1, and our AC is a times c, which is 2 times minus 6, which is minus 12. And the question is, which two numbers, when we multiply them out, they will give you -12, and when we add them out, they'll give you -1. And it goes without saying, this is just -4 plus 3, and -4 times 3. The only thing that we need to do now is to break the middle term and substitute it, and we have 2x squared minus 4x plus 3x minus 6 is equals to 0. Within the first two terms, 2x is common, 2x is common. Within the bracket 2x squared divided by 2x is x minus 2. Those are common, and then within the next two terms, 3 is common, x minus 2, which is 0. This bracket has to be identical to that. And of course, the outer terms form a bracket of their own. So 2x plus 3, x minus 2 is 0. This is a situation whereby when we have two numbers multiplied and the product is 0, it is either one bracket is 0 or the other bracket is 0, or even both of them are 0. So if we take 2x plus 3 to be the one which is equals to 0, it follows that here x is equals to minus 3 over 2. If it is now x minus, or the second bracket, which is equals to 0, it follows that x is equals to 2. And that is just like it. And we just now need to substitute some of these solutions in any of the original equations. Let's talk about equation 1. or equation 2. When x is minus 3 over 2, y is equals to 2 multiplied by minus 3 over 2 squared, which is 9 over 4, which is by 2 and by 2, 2, which is 9 over 2, or rather 4 and a half. So when x is now 2 equals to 2, y is equals to 2 squared. This is 4 times 2 is equals to 8. So we are having coordinates minus 3 over 2, 9 over 2, and or 2, 8. Those are the point of intersections within the two graphs. If we construct them, if we solve this equation now graphically, that is, or those are the pieces of solutions. Incidentally, we are also told in the question, show the results graphically. When we are expected now to show the results graphically, we have no choice apart from just constructing a graph of the two. And let's start with the graph of the quadratic function. The graph of the quadratic function, y is equals to 2x squared. Let's have the y-axis there, and let us have the x-axis here. We don't need so much the negative values of x. We don't need so much the negative values of y, rather. So we can always have our x-axis here. Let's have our x-axis there. Let's have 1, 2, 3, 4, and -1, -2, -3, -4. And let's have now the values of y's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just have that. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And let us just have the plotting now. To start with, the graph of y is equals to 2x squared. Let's have x and y here. The graph of y is equals to 2x squared. Let us have x and y here being tabulated. When x is minus 3 squared is 9. 9 times 2 is 18, far above our axis. When x is minus 2 squared is 4. 4 times 2 is 8. When x is minus 1, we can have minus 1 squared is 1 times 2, 2. 0, 0. Let's have 1. 1 squared is 1, 2. Let's have 2. Again, 8. Let's have 3. 3 squared. 3 squared is 9. 9 times 2, 18. And you can always now plot that graph. Let us plot that graph. When x is minus 3, y is 18. When x is minus 2, y is 8. Minus 2, 8 there. When x is minus 1, we have 2. When x is 0, we have 0. When x is 1, we have 2. When x is 2, we have 8. And when x is 3, we have y being equals to 18. And it goes without saying, now we have to have a curve, very smooth curve here. It is a curve, it's a quadratic graph. It is a quadratic graph. It is a quadratic graph that we have to draw using freehand and very easily. That's the graph of y is equals to 2x squared. Let us have the graph of y is equals to x plus 6, x and y. This is the easiest to draw, because when x is minus 6, let's say when x is minus, let's say what? When x is 0, can we even start from 0? When x is 0, y is 6. That is true. When x is, what about when x is itself 2? This is a straight line. 2 plus 6, that is 8. These are just enough because it is a straight line. So we talk about 0, 6, and 2, 8. As much as this one is produced, we can have that graph passing through these 2 points. A very good straight line, and there we are. So we can have, that is the straight line, and we can name it and call it y is equals to x plus 6. Fine. When we now interpret it graphically, we can see the point of intersection. This is when x is minus 1.5. This is where the graph meets, so we can talk about this. X is negative 3 over 2 minus 3 over 2. So minus 3 over 2. What is y when we are there? Of course, you walk with this straight line. 4.5. This is 4.5 or 4.5 or 9 over 2. At this particular point now, this is the point of intersection. X is 2. It goes without saying. You can see if you drop down, you'll read the value of x being equals to 2 and the value of y being equals to 8. And those are the 2 solutions, which has been proven graphically. Minus 3 over 2, 9 over 2, and 2, 8. So if you compare, this is exactly equals to that, and this is similar to that. So we have solved the 2 simultaneous equations algebraically, and we have also used the graphical method to actually support our answer. So we can make one conclusion. We can either solve simultaneous equations algebraically, and we can also solve them graphically. Thank you for following me. Let us meet in the next video. Thank you.